would like to introduce Chrome OS. Chrome OS was officially released by Google in 2009. It is built on the Linux kernel and was designed mainly for web application and cloud computing. Chrome OS is pre-installed on Chromebook devices and is commonly used in school, office, and for personal computing. One of the main features of Chrome OS is that it focuses on internet connectivity and online storage. It is also compatible with the Google Chrome Web Store and Google Play Store, allowing users to install various applications easily. Chrome OS has many advantages. It is lightweight and fast, easy to use, and has a quick boot up process. In addition, it provides automatic system update and strong virus protection through sandbox security. This operating system is suitable for users who mainly use browsers, online documents, and cloud service in their daily tasks.
To understand Chrome OS, think of it like a secure multi-layer building, moving from the physical hardware at the bottom up to what we see on our screen. Here is how it works. First, the hardware layer. This is the physical foundation. It features the Titan C security chip, a custom Google chip that acts as the hardware root of trust. It protects encryption keys and makes sure the computer boots up safely without tampering. The kernel layer. This acts as the bridge connecting hardware to software. Chrome OS uses a monolithic Linux kernel that has been heavily stripped down and hardened. By removing all unnecessary code, the system becomes much faster and harder to attack. And next is OS service layer, which is a middleware. This is the background engine. It uses a system called dbus to let background process talk to each other safely and securely. And lastly is application layer, which is user space. This is the top floor that users interact with. It runs the Android and Linux app in isolated containers. The main interface is a web platform powered by Chrome, meaning even standard apps like files and settings run natively using web technology. This entire stack is wrapped in a verified boot process and gets seamless auto updates in the background to stay secure. Now, why is Chrome OS built this way? It all comes down to two main principles. First, defense in-depth security. Chrome OS is built with the assumption that malware will try to attack, so it uses multiple walls to stop it. Like sandboxing, every web page and app runs in its own isolated box. If you accidentally click a malicious link, the virus is trapped in that single tab and cannot infect the rest of the computer. The other is read-only root file system, which is the core system files are permanently locked in read-only mode, meaning malware physically cannot modify or damage the operating system. Second, stateless user data. This separates your data from the physical machine. For example, local encryption. Anything saved on the device is heavily encrypted using a hardware TPM chip. And next is cloud synchronization, because your data is instantly synced to the cloud. The laptop itself is stateless if your Chromebook gets run over by a truck. Your data isn't lost, you just log into a new one and your entire profile is restored in seconds. In short, Chrome OS is designed to be fast, unhackable, and cloud first, so your data is always safe no matter what happens to the hardware. Thank you.
Next is process scheduling. Process scheduling is the way the operating system manages CPU use so that multiple processes can run smooth at the same time. In this system, the kernel scheduler is responsible for determining which process should run first, with a domain of balance, performance, and energy efficiency. In addition, Chrome OS uses a concept called core scheduling. This concept allows processors in the same group to safely share CPU resources so as hyperthreads. This is important to ensure system security and avoid interface between processors. The system will also choose processors with higher priority to run first and manage the CPU queue so that all processors get a fair change. Next, this process scheduling is used in several situations such as the Chrome browser, virtual machine, and even Android contents, where each is isolated to improve system security. For example, when we use an application like Netflix, the system will give priority to video playback so that the preview does not lag or buffet. At the same time, we can stay open other applications because the CPU will be divided fairly. In conclusion, process scheduling in Chrome OS is very important that ensure the systems remain smooth, support multitasking, and provide a better user experience.
Today I will explain about deadlock handling. This slide explains how Chrome OS handles deadlock. A deadlock occurs when processes wait for each other resources, causing the system to stop responding. The diagram shows a calculated rate, which is a common deadlock situation. Chrome OS reduces deadlock through four methods. First, process isolation, which separates application. Second, sandboxing, which limits application interference. Third, resources management, which efficiently controls system resources. And last, automatic process termination, which stops unresponsive process. Last but not least, this technique helps Chrome OS maintain stable, secure, and smooth performance.
Today I will explain about file and directory in Chrome OS. A file is a collection of digital data such as documents, images, videos, and audio. A directory or folder is used to organize and manage files. In Chrome OS, users can access and manage their file through the Files application. There are three main directories in the Chrome OS. First is My File, which stores file locally on the Chromebook. Second is the Downloads folder, which stores file downloaded from the internet. Third is Google Drive, a cloud storage service that allows users to save, access, and synchronize files across different devices. Next, Chrome OS supports file management through keyboard shortcuts and Linux. Common keyboard shortcut include Ctrl plus C for copy and Ctrl plus V for paste. In the Linux terminal, users can use commands such as ls to display files, cd to change directory, mkdir to create folder, and rm to remove file. Lastly, file permissions are used to control access to files and directory. There are three types of permission like read, write, and execute. These permissions help improve security and protect user data from unauthorized access.
So overall, Chrome OS is a lightweight and cloud-based operating system that provides fast performance, strong security, and efficient resource management. Chrome OS also supports multitasking, download handling, and file management to ensure smooth system operation. Additionally, features such as sandboxing and cloud synchronization help improve security and user convenience. Therefore, Chrome OS is suitable for daily use, especially for users who rely on web application and cloud computing.